Hello, friends. Welcome to the Nexus Podcast. I'm your host, James Dice. Each week, I fire questions at the leaders of the smart buildings industry to try to figure out where we're headed and how we can get there faster without all the marketing fluff. I'm pushing my learning to the limit, and I'm so glad to have you here following along. This episode is a conversation with Casey Collins, Assistant Director of Energy Management and Data Systems at Duke University in Durham, North Carolina. We talked about Duke's campus decarbonization and digitization journeys, how intertwined those two journeys are, the important technologies they're implementing, and the challenges unique to the higher education space. I enjoyed meeting Casey, who's a longtime listener of the show, and thought this was a great addition to our higher ed series that's including Stanford and Monash. So without further ado, please enjoy this episode of the Nexus Podcast with Casey Collins. Casey, welcome to the show. I'm so excited to have you on. Can you start by introducing yourself?
Sure, James. Thanks a lot for having me. My name is Casey Collins. I do a lot of things. Right now, I get paid by Duke University. I'm the Assistant Director for Energy Management and Data Systems. And then I also have an interim role as the Director of Utility Operations for our campus.
Got it. Okay. I want to go back in your career a little bit, but first I wanted to ask you about your LinkedIn profile pic. It's a picture of you on a backpacking trip, I think. Are you an avid backpacker?
I am. Yep. Thanks for asking. And that you're right. If anybody looks up my LinkedIn profile, you'll probably squint and try to figure out what the heck that is.
I tried to click on it. And...
Yeah, I am. I enjoy the outdoors in all sorts of ways, but definitely enjoy getting outside, being outside without being off grid, right? For as much as I am professionally in the grid, I enjoy the opposite of that in my recreation.
Nice. Any particular places you like to go?
Yeah. So, I mean, I live in North Carolina, 3 hours from the mountains and 3 hours from the beach. So a whole bunch of places in the Blue Ridge that are great. Have been lucky enough to go down to Peru a couple times, hiking the Andes, which was
awesome.
An amazingly different landscape. And then I haven't been out west to the Rockies in a while now, but look forward to getting back out there in the not too distant future.
Nice. Well, I have a book recommendation for you, but I'm going to save it for the Carveouts section at the end. So tell me about your career before Duke. I'd like to know like what your educational background is and sort of your career progression to get to where you're at today.
Yeah, sure. I'll too. So I'm a mechanical engineer by education. I went to NC State and I did a handful of things late in my college career, engineering wise, before I sort of figured out where I wanted to be. At one point, I interned for Philip Morris Tobacco, which is, big industry in the Southeast, and I did a couple other machine design type roles and then realized that wasn't for me. But I got into sort of the energy world initially as a young engineer doing, mechanical, electrical, plumbing design for a production firm, and did a whole lot of commercial HVAC type design. I realized that it was a little too cookie cutter for me. Went back to work as an owner operator in the higher ed space. And that was my first exposure to larger district energy systems, the bigger toys, chillers and boilers and power systems that are part of that. And then went out to work for an energy services company, largely doing industrial energy stuff. I got really into some pretty old technology. I got to be an expert steam system guy, which was great and fun, right? As an earlier industrial revolution, but got to be very good at that. And then actually ended up coming to Duke University because of that steam system expertise.
Oh, wow.
Initially, I've been at Duke now for a little over 11 years.
Okay.
With probably 4 or 5 different roles. It's been some time since I would have described myself as an engineer. I would probably, in a professional setting, tell people that I'm an energy professional. I'm not doing as much. It's been a while since I've done design work, but I've had a variety of energy management roles here specifically, and in some progressing leadership opportunities too. So, and this current one has me leading this energy management and data team, which is about 10 folks, executing a handful of supply and demand side management, and again, data management projects. And then now as the interim leader of our district energy services. So that for us, that's chilled water, hot water, normal power distribution, emergency power, water, sewer. We are a utility company effectively inside of the university and health system, but we just don't have any public customers. It's all Duke entities.
Got it. Yeah, it's been a while since I was practicing engineer as well, and it's difficult to know what to call yourself.
Right.
Yeah.
If you're at a family reunion, I'm an engineer. If I'm at a conference, I'm in energy, right?
Yeah. Yeah. Mine's even more difficult. It's like, am I a podcaster? And so tell me a little bit more about Duke's campus. Obviously, I've
Yeah.
been there before, played soccer there. You might not know that. I did not play soccer there. I played soccer against Duke at Duke. I went to St. Louis U, and
Okay.
while my generation of Billikens didn't beat Duke, the last season they beat Duke, so I'm always tracking NCAA soccer still. But yeah, tell me about the campus. How big is it? Is there a medical campus, or is it just academic? Yeah, a little bit more detail would be fun context for the rest of this conversation.
So Duke University's main campus is in Durham, North Carolina. It has about close to 21 million square feet. And that's the university proper. That's the stuff that you see with the ESPN flyovers if you're watching sporting events. But the majority of our campus is actually health system and research facilities. So the university proper is about 7 million square feet. That leaves, 13 to 14 million square feet of healthcare. Okay. And that the role that I fulfill has obligations to both sides of the house. We are officially part of the university. Our energy systems, our utilities serve the entire campus. And so from a supply side management perspective, I'm responsible for that full 21 million square feet. Okay. From a demand side management perspective, actually executing like ECM projects in buildings, it's about that 7 million square feet of university campus. And what I tell people generally is that we've got this huge real estate portfolio effectively, and we have built one of anything that you could possibly put in a building, like is basically what we have on this campus.
Mm-hmm. Got it. That's hilarious. So can we do a little translation for people that aren't energy people? So if you're coming at this from a technology standpoint, we're going to talk about technology for sure. But if you might not understand some of the stuff that Casey just said. So ECM's energy conservation measure, supply side is power or natural gas supply to the building from the utility. And then demand side is, all the different things in buildings that use energy. So talking about managing those and probably reducing them. Essentially.
That's right. Yeah. Yes, we do not aim to increase. And I'll add like one more quirk to that. Sometimes when I talk about supply side, I mean exactly what you said, which is public, taking custody of natural gas or electricity or the public utility entities. But sometimes, and I'll try to be clear in this as we go along, but I mean the district energy services that provide everything to our campus. So we don't just have boilers and chillers at individual buildings. We operate these large district heating, cooling, power distribution systems that are delivering that energy around campus, right? So we're piping 50,000 tons of cooling around campus and 300 and so odd 1,000 pounds per hour of steam and hot water to heat and cool all our buildings. So
got it.
I'm all like right, cool. Middleman, supply and demand.
Right.
Manager.
Well, cool. So, and also we should add a disclaimer. So you are talking about Duke. Is there anything you want to say there?
Fair point. Yeah. So Duke University is so big and so diverse that I certainly can't speak on behalf of the university. My opinions are my own. They are entirely related to my role here and my profession and how I operate in that ecosystem, right? Only the trustees officially speak for the university. So I'll throw that caveat out there and But we'll also try to be professionally responsible and courteous to my employer.
Totally. All right, I'd love to start with decarbonization. So can you start by kicking us off and just explaining what's Duke University's climate target and kind of where you're at on that journey to get there?
Yeah, great question. Duke University has committed to climate neutrality by 2024, which is not too far off. We're recording this April 22. So starting in 2008 and 8 to 9, Duke developed its initial climate action plan. And that was when the target date was set. That coincides with the 100th anniversary of the Duke Endowment, which is when Trinity College became Duke University. And so we've been, at least in my time here, on a decarbonization march. Okay. That's been a handful of easy pickings and some more difficult to achieve things. We still have on the neighborhood of 170,000 metric tons to offset.
Okay.
Or reduce or eliminate, right, in some fashion. And our carbon footprint is about 2/3 related to stationary energy, right? So the energy that it takes to power our buildings. That's mostly scope 1 and scope 2 emissions. And then that other third, and I'll go ahead and say COVID has kind of thrown a wrench in some of this metrics, but that other third comes from transportation related activities. So both faculty and staff commuting to and from campus, and then air travel on behalf of Duke, which is substantial, and not just for athletics, substantial for all the researchers that go around the world and talk about whatever Duke is doing.
Okay. Yeah. So that would be included in scope 3, and you're trying to do climate neutral, carbon neutral on 1, 2, and 3.
That is correct. That's correct. Yeah. The largest single contributor to our emissions profile are scope 2 emissions associated with electrical energy delivery.
Okay. Got it. And then is there a target that's past that? Because as you know, the industry is kind of moving past carbon neutrality a little bit. Is there another goal after that?
Not yet. I absolutely see that coming once we have the fully put in place that initial carbon neutrality success. And that's a combination of, again, supply side strategies, decarbonizing our energy supplies, a fair amount of energy reductions, and demand side management, and then carbon offsets are absolutely included in that. The scope 3 stuff is really hard to fundamentally offset.
Yeah.
I'm sure I'm not the first person to mention this, but for example, there's not a lot of alternative low carbon commuting options for folks in Durham, North Carolina. So the majority of the workforce drives to campus. Until everyone has a fully renewably charged EV with offset supply chain, emissions in the lithium ion space, then that's a tough one.
Yeah. Same with flying to conferences in Barcelona to talk about your research paper or whatever.
Correct.
Yeah.
Correct. Yeah.
So let's sort of confine this conversation to just the buildings and campuses. So the scope 1 and 2 that are related to the buildings. So how do you think about offsets when it comes to those? Or are you trying to get all of the buildings down to some zero carbon state at some point?
Yeah, great question. So it's more supply side decarbonization right now than it is demand side. We have facilities that demand a ton of energy. The hospitals, optics labs, we have a clean room, we have a data center, like all of those things need energy to do their primary use, right? They need access to modern energy, and that's electricity and heat. And so, for example, we've got a commitment coming online actually at the end of this year. We'll have effectively a VPPA, virtual power purchase agreements, sleeved through a green tariff to get about 50% of our annual electrical needs through brand new PV development just for us, right? So that's a supply side strategy. We've been heavily involved in the renewable natural gas development space. That was a research extension project that then led to Duke University as both a commercial entity and a research entity, really leading a lot of that conversation in North Carolina and in some ways the Southeast. So we publicly announced, during COVID, that we've got a substantial renewable natural gas buy. That's going to be part of the it's not quite an offset, right? It's an actual decarbonization of the fuel supply, although it has an associated environmental attribute. But that's coming from a source in South Carolina with a developer that we worked with really hard some on the technology side, but also on the regulatory and policy side to make that happen. And so we're looking at those two major, supply side plays, and then everything else looks like energy efficiency gains plus some hoping to fill in the margins with offsets, right? We do not want offsets to be our primary decarbonization strategy.
Right. So most of the time when people talk about heating and decarbonizing heating, they're talking about electrification. I imagine with you guys with this massive steam infrastructure, that would be challenging. So can you talk about I'm assuming the renewable natural gas is feeding the steam boilers, which would then heat the campus. Is that why you went that route? Is because you had that existing infrastructure?
Yeah, that's correct. We are pursuing heating decarbonization through electrification. And for us, that really means getting buildings off of a steam supply and onto a hot water supply. Okay. And then moving that hot water production over to some heat recovery chillers. Yeah. Right. So combined heating and cooling systems. Again, that plays into our PPA and VPPA conversations. Which are somewhat limited because of our regulatory environment in the Southeast. We're not part of an RTO or an ISO where we can just have full freedom of economic activity. But yeah, about 2/3 of our campus needs a higher grade of heat than just what heat pumps can provide, right? And that's the hardest part, not just technology wise, but one of the harder parts technology wise to actually electrify. And so, yeah, we're in on natural gas, renewable natural gas for that. We hope to be out of it at some time in the future, right? I hope for heat pump technology to continue to get better. In fact, like that seems to me like the mechanical engineering problem to solve in the 21st century, right? Is how do we get heat pumps to make just a little bit hotter heat, and then run those off of some renewable power. But
got it.
Okay. On an annual basis, though, like the source energy coming in, about half of our annual energy is in the form of natural gas because of that heating footprint. Yeah. Which on the surface makes no sense for a campus in North Carolina because we're a cooling dominated climate.
Cool. So let's talk about performance of individual buildings then. How do you think about, you have this bigger target, and then now each building needs its own target to sort of fit in with that larger target. What do they need to get to? And then how do you envision getting, each building to their individual targets? How does that work?
Yeah, it's a great question. So I'll say I don't set an explicit EUI or even just, source annual BTU target for individual buildings.
Okay.
I do care about the aggregate because I own and operate this massive district energy system, right? Yeah. So, unlike a I don't know, a REIT, like a commercial real estate portfolio owner, I don't need to plan for every building to be PV ready. I don't need to plan for every building because it's our buildings don't operate as islands. They operate as part of this campus. That being said, in aggregate, the initial goal set forth in the climate action plan was to reduce on an EUI basis energy consumption by 15%. We will need to accelerate that to some much greater level to reduce the offset purchase requirement to get to climate neutrality.
Okay.
And then, the economic flip that the economics that encourage that is that, when we reduce our energy consumption, we both reduce that raw expenditure, and we reduce the amount of money that the university as a whole would spend on carbon offsets, right? So we can put a price on carbon and include that in the life cycle cost calculations.
Got it. Okay. I do want to circle back to that price on carbon in minutes. I'd love to ask you though, so each building has its, EUI target, or if you don't have an EUI target, an EUI reduction, like you said. I'd love to ask you about just like the role of retrofits. So you guys have been on this road since, 12, 14 years ago, something like that, right? So I'm assuming that most of the easy stuff, when we talk about energy conservation measures, has been done. You install controls, you optimize buildings, or you optimize control sequences, schedules, all that stuff. That stuff is kind of like the low-hanging fruit, as I think about it. If in order to get to the next jump in a reduction, you need to do some sort of retrofit, like this entire system needs to be converted over to this new system type, right? Like a heat pump, heat recovery chiller, like you talked about. So those are bigger projects, bigger capital costs. How do you think about across 7 million or even 21 million square feet for your counterparts over on the medical campus? How do you think about like all of these retrofits that need to happen and managing them and that mess that takes?
Yeah, right. It's not easy, and it is a lot of money. I mean, let me kind of walk up to that. Well, let me first reconfirm that yes, like all of this sort of, I'll say easy stuff, all the low-hanging fruit, to use the energy management industry language, is mostly picked over. And that's not been that easy for us. We operate in a market where energy is extremely cheap. I've not yet crossed the 6 cents a kilowatt hour barrier. And, you've got, I'm assuming there are listeners that are double, triple, maybe quadruple that. Right?
Yeah, definitely.
And so what that means is we have done, big lighting retrofits. We've done big water retrofits. We've got DVC controls throughout, right? We'll circle back to your comment about scheduling and maybe like occupancy awareness in a little bit, because that's a thing that is very different for college campuses than the sort of thing I would practice in a commercial or industrial setting. So that being said, like we've got the like late 20th century, early 21st century technology and stuff covered. That's gotten us a long way from where we were 10 years ago in terms of decarbonization. I think we go a couple different places from here. And this is really more about program management than it is technology. I care a lot about I'll say like inside my own organization, selling the co-benefits that come with energy efficiency. So when I do an energy efficiency project, or ask my team to put together an energy efficiency project, it's their job to get off the energy island and go get integrated into the other conversations that are happening when we plan a project. And so, as an example, we rolled out a automated fault detection diagnostics platform close to 2 years ago. My team lead on that, fantastic engineer, but his highest value is in being a connector to the other parts and pieces. So he's working on confirming the actual workflow from the fault detection platform output to mechanic resolution, which means that he's got to go talk to the maintenance supervisor of the HVAC shop, and he's got to talk to the planner scheduler guy, right? He's got to like make a bunch of these things happen. And so much more of my strategy around decarbonization and even just energy management as a cost reduction measure is more about team and organizational building than it is technology. That might be hiring staff inside, but that also means managing well-managed vendor relationships. The AFDD is one example, but there's lots of co-benefits to this, that are it's maintenance cost reductions. It's like material warehouse consolidation, trying to align your repairs and your shelf stock with stuff that's consistent. When we move up to sort of like the district energy supply level, right, there's a conversation to be had that energy conservation in a building, whether it's a retrofit or new project, also defers massive capital investment in that big chiller or boiler system.
Right.
And so we try to appropriately and conservatively wrap all of those decisions into our projects. And that means more people, that means more information, and it really means better organized information. We are we could go like 1,000 directions with this one comment. We won't, I don't think, but we are the building world, not just the engineering world, but the building operations world, whether people are aware or not, is just drowning in data. And I think I've heard, I know you've had a couple of guests talk about this, but we're drowning in disorganized data is what we're drowning in. Like we're not appropriately using the information coming out of our systems to make better decisions. Some of that is technology, right? Not every piece of hardware has a machine readable connection to this other thing. And so my technology approaches are much more about the integration of these other things that I have, and then building teams to use that information and actually go do something.
Got it. Yeah. And I'm just picturing like all these projects you talked about with all this information, all this data that's not very well organized, and then all these different stakeholders that need to use the data. Right. It just, to me, it just like begs for something more sophisticated than a spreadsheet. And I keep talking to people and they're like, yeah, well, I have this big ass ECM spreadsheet that has all the projects in it. And I'm like, how are you able to manage this complexity with a couple tabs and an Excel workbook? How does that work?
That's a great question. Okay, so I have one of those spreadsheets. I will absolutely confess to that. I've not seen a commercial product that does that better yet. And there's an opportunity, right, for somebody to make something that is, I'll say, semi-customizable, right? The thing that I think our industry misses is that we have folks that offer like fully customized solutions and folks that offer like out of the box stuff. But, like Trane will sell you the same air handler, whether you're like a 50,000 square foot office building that's being built as like shell and core, or if you're a world-class research institution, right? It's the same stuff with like basically the same controller. So we've got all these little modular things that are just begging to have like just enough time put into the integration or just enough time put into the economics of, I don't know, a cost management database for project development, so that you don't have to reinvent the wheel every time, right? Yeah.
Fascinating. Yeah, I agree. There's tools out there, and the jury's still out on whether they're better than the current tool that's doing the job today.
Yeah, if I could, like, the the sort of horizontality to make up a word
Yeah.
isn't totally there. I think
Mhm.
in our industry, got a lot of legacy vendors, software providers, hardware providers, whatever technology they're in, that want to sort of give you everything they think you need, and that doesn't work for the next century of
Yeah.
facility management, engineering, the energy sphere.
Yeah. Yeah. A good example there, I feel like, is projects happen. Maybe it's not an example, but it's more color to that. Projects happen in so many different ways throughout an organization like yours. It could be a simple preventative maintenance task. It could be a work order that goes to an external contractor. It could be the energy team doing some sort of upgrade. It could be the capital projects team.
Yep.
It could be like, you could probably go on and on and on thinking about all the different organizations. It could be a renovation, or it could be like, we have to decarbonize this building really quickly, and therefore we need a heat recovery chiller, right? It could be outside of the normal replacement timeline. It could be on the decarbonization timeline. There's just so much, if you think about horizontally, so much across the organization and complexity that goes into project planning these days.
Right.
Fascinating. I'd love to talk more about the campus. So how higher ed is unique? So you mentioned scheduling and occupancy. So can you talk more about that?
Yep. So for those that have worked in the energy management field, I think there are efforts, there are like the easy baseline efforts that you might do in other commercial settings that I just can't or won't do. And that's been something to work around in this sphere more than others. So for example, I remember early in my career doing an energy audit for a Fortune 500 client with a large presence in the Research Triangle region. And, part of that energy audit was just basic equipment utilization and space utilization evaluation, right? We walked into a place and said, you know what? You've got like 4 buildings that are 10% occupied. Why don't you take all of those people and put them in one building and then shut 3 buildings down, right? And then they went and did that,
Yes.
That doesn't happen here. And it doesn't happen on a lot of higher ed campuses, because the default assumption on how people use these spaces is that they are open at any time for anyone for any reason. COVID changed that a little bit, but we're already seeing maybe regression's not quite the right word, but I'll go and use regression to that really open operation and open campus. The richer your campus is, the more you experience that. And I mean, like, in terms of just material and space wealth. And so the sort of occupancy awareness, and sometimes lack thereof, which includes a huge value judgment about privacy and the value of privacy, in the modern world, that is very different than the conversation being had at, say, retail environments or even commercial real estate environments. That lack of full occupancy awareness means that I'm spending a whole lot of time working on, scheduling HVAC equipment in the BAS, or talking about lighting control in a very different way. And so what that means is that there are times for which I have to make a technology decision, and I'll use lighting control as an example. I actually don't want, because no one in my team can manage like a lighting control system, regardless of how the data is acquired and how we can manipulate schedules and everything like that. Like, we don't want to manage that, because there's too many people trying to use the lights in too many different ways. So that means that we're inclined to say, okay, what you really need is like just a single room lighting scene controller, and with maybe some vacancy or occupancy sensors, right? That may not be giving me a whole lot of information feedback, but it is entirely optimized for the use case of that space. The same could be said for some HVAC operational control and a little bit of water management, but not too much there. And so that's a major cultural difference, I think, in the higher ed space, is that you are absolutely not necessarily reacting, but absolutely working around this expectation that the campus is open and free. And that's an amazing thing, by the way. That is an amazing luxury to be able to experience, but challenge for the energy management profession.
Yeah, definitely. Do you see that changing? So if I think about, hey, this campuses as a whole across the US, across the world, are setting decarbonization targets, and where my mind has gone when I think about that, I think about like carbon emissions per enrolled student per year or something like that.
Yeah.
And maybe it could go in that direction where it's like, okay, well, the campuses that have this abundance in terms of space will now start to view that differently in terms of it's not just about the student experience, it's also about getting that carbon per person down. Do you see that changing?
Yes, I do. And it will change, I think, for the reasons you mentioned, as well as the need for what one of my colleagues would just term growth in place. So
Yeah.
there's plenty of campuses that exist in, I'll say, pastoral, semi-rural environments, and maybe that's a little bit different for them. We're in a semi-urban environment. We have a huge green space, and a beautiful tree canopy, but we are just adjacent to a quickly growing city, and a lot of campuses are like that, right? So real estate gets more expensive. The way in which operators utilize their buildings and how efficient they are at scheduling the personal activities inside of them becomes very important to the long-term financial health of the entity. And so that's driving it, as well as, of course, the decarbonization you mentioned. We're not publishing, sort of like a per capita carbon intensity score for the campus, right? We actually probably could do that, on average, but that becomes a really important part of how we talk about it. And really, that's just resource utilization, right? That's asset management. How do I best utilize my assets to do the thing that I need to do? Again, tricky on a college campus, because what do you say you do? Like, people say like, well, what does Duke do? Like, Duke is like one of everything. Duke's only trying to be the best Duke. It's not trying to make tires more efficiently or less costly. It's not making paper. It's not running it. It's not, we're running a sports arena, but among other things, right? But not as a commercial venture. So,
Right.
that's like my other main, challenge around, defining the case for energy management, is that if I, again, like harkening back to earlier points in my career as a point of comparison, if I did an energy efficiency project for Unilever, I could tell them that it saved them X cents per stick of deodorant that they made. There's not an equivalent here. So.
Well, I think so. These are certainly unique to your situation, and they're probably very similar across other, elite institutions. These same patterns, though, they show up in other industries and other building types, right? So I think, just as Duke is trying to create the experience for the Duke student that is the best, the best 4 years, the best, on campus day in the life, right? That they're able to do. Office buildings are trying to create the best experience in the office. Retail, same thing. Like, I think that each industry, and we can't act like these obstacles aren't there as far as, decarbonizing. Each industry is there so that the building can perform some overall job to be done for the user or for the owner in some way. And I love that you pointed out that these are the things that I have to deal with in my organization. And then everyone has to figure out what their obstacles are or their unique circumstances are.
Yeah. Point well taken. Absolutely true.
How about, so you were talking about earlier, like sort of like what the next goal might be after carbon neutrality in 2024. How do you think about like 24/7 clean energy targets, or what do you think your target might be? And then like, how are you going to make that decision?
Yeah. So I don't think a 24/7 clean energy target is the next thing for us. I think folks know what we're talking about here, but that's the idea that every hour of every day for an entire year, right? Clean energy is what's serving you as a source. That is, I'll say, specific to us, that is difficult because of the regulatory environment we're in. If I'm beholden to a large and influential public utility, that means that I can't go do all the PPAs I want to for renewable sources. Even if I could. The one thing that I'll say I'm a little bit conflicted about with regards to that point is that, entities like Duke University and plenty of other commercial entities that have made these big decarbonization pledges, I think there will become a point where, and I don't think it's that far off, where their own self-interest may or may not be really aligned with the other public energy systems that are out there, right?
Hmm.
So at the end of the day, it doesn't really matter if Google, and I'll pick on Google just because I know they've come close to making this claim.
Mm-hmm.
It doesn't matter if Google is getting 8760 clean energy if the other 95% of the public utility grid is still dependent on other higher carbon resources, right? And so I think that's what's happening right now. And that's what will happen at Duke University. Duke University seeks to use its dollars to do something good. And it just our next conversation has to be about the alignment between our good and everybody else's good, because we don't operate as an island. We are highly integrated into our community, highly integrated to our state. Everybody that lives or works or studies or researches at Duke is also, a person with other things that they do. And so I look forward to being part of that planning process,
I was going to say,
and having, that's a great and fantastic thing to be able to have the professional opportunity to do. I hope that we can continue to influence some of the public policy that does, limit us from the regulatory basis. And what that means for us is that for every way that I can get a regulatory change that lets me buy more clean energy, it's the less money I'm going to spend on carbon offsets. Mm-hmm. And there's a local economic benefit there, right? We would intend to buy and have built, in our own backyard as much clean energy resource as possible. I do not wish for my carbon offsets office, who are colleagues of mine, to have to search the world over to go find offsets that they can find, at some reasonable benefit. So.
Totally. Hey guys, just another quick note from our sponsor, Nexus Labs, and then we'll get back to the show. This episode is brought to you by Nexus Foundations, our introductory course on the smart buildings industry. If you're new to the industry, this course is for you. If you're an industry vet but want to understand how technology is changing things, this course is also for you. The alumni are raving about the content, which they say pulls it all together, and they also loved getting to meet the other students on the weekly Zoom calls and in the private chat room. You can find out more about the course at courses.nexuslabs.online. All right, back to the interview. All right, let's talk a little bit more. You mentioned price on carbon earlier. I'd love to hear, as we're talking about higher ed specifically, how you make the business case for maybe let's zoom out a little bit. Instead of just talking about energy, talk about building technologies as a whole. What business cases exist, and how do you sort of make the business case for technologies that you implement?
Yeah, sure. So the most immediate business case for a price on carbon for our campus is that it defers an offset purchase, right? Just to scale it for listeners, you can get really cheap, I'll say low quality carbon offsets for less than $5 a metric ton. The stuff we're targeting, which has more co-benefits typically, is north of $20 a metric ton. Those are offsets that would also align with the other values and goals of Duke University. And so that portfolio has a price range. It's not one single dollar amount. So when we run a life cycle cost analysis, we include the cost of that offset. Okay. That means that a more efficient solution that uses less energy and thus has less carbon footprint also benefits from not needing a carbon offset to be purchased for it, right? So, and that's a reasonably strong case when you actually run an analysis. If you put a price of $20 a ton or even $15 a ton on something, of course you have to run that math versus the capital or retrofit cost to implement it. But we have maintenance reduction goals, and maintenance cost management and renewal cost management goals that go into our life cycle cost analyses. Okay. And so they're absolutely a part of it too. Can you talk about how that the maintenance piece of that works? How does that work? Yeah, right. If you're looking at like a payback or life cycle cost analysis of a different project. Yeah, I'll give you a real example that I worked on last week. I'm in the last phase, the final planning stages of a last major LED retrofit phase for our campus. We've done two big ones, retrofitted over 5 million square feet. This last one is maybe about 1 million square feet of retrofit. If I just run the energy cost savings calculation, the simple payback on that project, and these are less utilized buildings that also need, in some cases, not just lamp replacement, but they've got old fixtures, so you got to replace fixtures. Simple payback on this project looks like it's like north of weighted average for the entire portfolio, north of 12 years, simple payback. Yeah. But if I consider the maintenance cost reduction because LEDs last a whole lot longer.
Mhm.
And our maintenance staff doesn't get dedicated to that. That payback goes down to like 4.5 years. Now, if you're in a market with more expensive electricity, that shift isn't quite as dramatic.
Yeah.
But that's what it looks like for me, right? So people can't forget that. And but my turnkey LED contractor did forget it, and they didn't put it in their proposal, right? And I even told them exactly what number to use. And the reason I know what number to use is that I actually have a billable rate for general maintenance mechanics and electricians and plumbers and HVAC techs. And when they go out to a department to do service, right, they actually have to bill that department for their labor time. And so, that cost, of course, there's a lot of baseline infrastructure that supports the ability to do that cost accounting for an enterprise like us. It's necessary, but that's what it looks like in real life, right? And so that means like 12-year payback. That's not a super attractive thing for a product that's got a 5-year warranty.
Yeah.
12 years doesn't look good when you think it's only going to last 5 years, but if it pays for itself in less than 5 years, and if I can get at least 5 years out of it, cool, fine. That's an okay rate of return.
Yeah. And how do you manage, you mentioned the department not having to pay the cost for the maintenance tech to come out to their building. How do you manage that split incentive where you guys centrally are, making the investment in the LEDs, and then the department that you're not billing for the energy and then not billing for the maintenance, they're actually seeing the benefit? How do you guys manage that split incentive across the
That's a
different
great question. Yeah. So in some cases, big picture story, I manage an energy project fund, right? That is, aggregated money from the operation of the entire university with the intent that I go and spend it on energy reduction and cost reduction measures. And so I don't have a hard line, but in a lot of cases, I spend that money as if I were like a utility providing an incentive, right? So as you noted, because we bill maintenance time and costs to buildings, we also meter and bill every single one of our energy services, right? Because we're effectively a utility. I have 1,200 meter accounts across campus. And we have a cost rate per kilowatt hour, per ton hour of cooling, per million BTU of heating that goes into that calculation. I would typically work with a department, and like every department on Duke's campus is one of my clients, and I treat that project development role very seriously. Like it's my job to go, not convince them to spend money, but convince them that, like, by doing this, they're aligned with all the goals of the university, and they actually can help them save themselves money in the future. It's a negotiation sometimes where they say, like, well, we can only put up this much, and then I kick in the rest, right, to get it to an economically attractive project. There are some that we just spend the money outright and go and do because it's just easy, slam dunk kind of project. And so I approach it. I mean, like, there's a very personal touch to that, and that's something I've found to be necessary here. And that's just because it's a very decentralized campus. And while we are all Duke and everything on Duke's campus, there are at any institution like this, I'll say, a fair amount of relative wealth and poverty, right? Some schools have a lot of money and a whole lot of donors, and they'll like just spend money on whatever. Some folks, maybe not so much. All of those folks are my team's clients, and we work really hard to try to transparently show them and help encourage them to do stuff that will benefit them. So.
Makes perfect sense. So I cut you off. Were there any other pieces of the business case that you think are unique to this situation?
Let's see. We talked about carbon maintenance cost, of course, energy recovery. We talked a little bit about deferred capital, right? So this might come into play where we have a project that, we run this math when we have a project that, like, may or may not get a connection to our district cooling system, for example, right?
Okay.
It's a building that could get its own on-site chiller because the pipeline to get it connected is maybe kind of long, and digging a trench and laying pipe is really expensive. It's $1,000 a foot. We would consider an architectural cost to that, right? If you don't have to put a cooling tower on site, then you either don't have to prepare that site, and there's a bit of a softer conversation to be had that not having a cooling tower on site is more aesthetically pleasing. Hard to put a number on that, but you can also say, well, like, look, this pipe's going to be in the ground for 50 years. You're going to have to replace this condensing unit in 10, or you're going to have to replace this cooling tower in 10, right? You you can pick the timeline of the life cycle cost analysis that aligns with that renewal cycle. And we get the luxury of doing that. I guess, Duke University builds buildings with the intent that they will last at least 100 years. Mm-hmm. Not everybody in the commercial sector does that, and I totally understand that. But you should still consider it.
Yeah. Okay. So I want to circle back on, energy software. You mentioned FDD, right? Those types of software applications. Can you talk about making the business case for those, but also can you talk about just generally your experiences with them and kind of how you approach that? You did mention earlier just having someone map out what I call the path to action for FDD, which getting from analytics insight to who's turning what wrench, when is it, can we check on it afterwards, all that. So you covered that piece already, but I'd love to hear just kind of how you guys approach that deployment and what the business case is for that.
Yeah, so I mean, the business case is entirely aligned with decarbonization, right? We hoped initially that FDD rollout, which a couple of years on from the planning cycle of this FDD rollout doesn't really, like, you're not done when you get the software stood up. Like, you're done when the thing gets fixed, of course. So many people forget that, by the way, especially FDD biz dev people.
Yes.
So
a couple of them will be listening to this. So
good for them. They should, right? I think the thing that we looked at, we initially started looking, I've been working on FDD for like 8 years.
Okay.
Early on, like to the point that like we were writing, I had a couple of people do, just proof of concept stuff, writing algorithmic comparisons in our BAS programming just to see, like, could we compare A to B plus C minus D? What does that tell us, right? Mm-hmm. That's not sustainable. We don't do that, right? And I have some very good engineers. We're pretty self-sufficient in terms of our automation system operation. But the vendor that we're using now, and this is we're still on the road, I'll say, was willing to be flexible enough with us in terms of their product and their integration, which means that it doesn't look as polished as other systems. Like the UI, the user interface doesn't look as polished as some folks out there. And let me acknowledge it's a little hard to talk about this space without talking about specific vendors, but I'll try to be anonymous or generic as much as I can here. Their rules engines were pretty simple. They were quick to say, yeah, we think we can do an energy calculation on this, but we don't want to put a cost metric on that, right? And so where I'm going with this, my FDD rollout so far is one that is meant to be semi-custom. There's only so many ways that a VAV box can fail. There's only so many ways that a hydronic air handling system with supply and return fan can fail. And there's only so many pieces of instrumentation. Like, that's sort of like the out of the box stuff. Yeah. A simultaneous heating and cooling fault detection algorithm looks about the same no matter where you apply it. The customization is really, and the time consuming part is entirely in the integration. We had a pretty good tagging protocol. Okay. Wasn't super tight. We've got a long legacy of automation systems. Not everything is, super new, and not everything is BACnet. But even with that, there was so much of that. So much of my engineer and contract support time was spent in that integration. Map, this tag actually means this thing out physically in the system. And from here on out, once that integration was done, it's been a whole bunch of just, let's customize the sort of reporting and visualization end of things, right? What are the ways that we can work with a vendor to build exactly that? I'll use the word dashboard, even though I don't like the connotation of that, but I'll say dashboard. Make that plot be the thing that, my guy can use to quickly say, yep, that's the problem. And I'm going to put a work order in our CMMS system. I can give this very exact guidance to the technician that's got to go out and fix that. So one of the things I've learned in this whole process is that, the more you can go faster than this, you meaning customer, facility manager, energy management professional, you can go faster the more typical your equipment is, right? If you got a bunch of rooftop units, you'll go 5 times as fast as I am. If you are, 100% Niagara or like all BACnet or all pick a protocol, you'll go faster than I have. And hopefully it means you got less problems, or you just have more of the same problem. But that's been kind of a journey there. Where I'm headed next, though, is a little bit trickier in that what I don't currently have, and this is this is entirely related to the size of the portfolio of stuff that I manage. I need our FDD system to also help me describe how a single building's impact affects the larger energy supply system on campus, right?
Yeah.
And I don't have that yet. And so that's a gap. There are folks that do FDD stuff for like plant optimization, right? Get my chiller stuff right. And there are folks that do it on the air side. For someone like us, I don't have the right quite solution
for both, the holistic system of systems.
That's exactly
you're
right.
saying.
Yeah.
That's interesting.
We're rolling out a different historian platform right now, just time series data historian, and that's great. We'll build some graphics and some informational templates there, but it's just, it's expensive to work with a systems integrator to customize, these type products and solutions. And they're great when you get them tuned, but it takes a lot of time and a lot of money. And so when I'm building the business case for this, it has to be at that larger campus impact decarbonization scale. The reason I can talk about decarbonization is that because whereas our campus is rather decentralized in all sorts of ways in which it manages itself, decarbonization is absolutely a central goal. It's in fact one of the few places where you can, even if nobody really knows what a metric ton means, it's one of the few places that we can find some alignment across the institution.
I'd love to follow up on the customization thing. When I think about customizing FTD software, I think about it and I'm just thinking out loud here, so I might add on, but I think about it in two categories. Again, TBD, depending on what comes out of my mouth here. But I think about it in terms of making sure the software can be applied to all the different types of equipment on campus, right? So you mentioned you have one of everything earlier, which, so if you have this like cookie cutter FTD software that expects every air handler to operate in the exact same way, that would need to be customized to fit all these different air handlers, right? And then I also think about it in terms of the data modeling and rule development type of customization, in that I want to be able to, like you said, I want to be able to write a custom rule that tells me custom rule or analytic results. I want to be able to tell me what percentage of the central loops load this building is contributing on the peak day of the year or something like that.
Right.
Like customized analytics, right? So when you say customization, which of those are you talking about? Are you talking about both, or are you talking about something else? Okay.
Yeah, both for sure. So you're right about the application specific end of that, right? It's this air handler is a little bit different. It needs to be, and then the report, the analytics end of it too. We have probably a larger need for the more sophisticated analytics just because of what we're doing. Yeah. But again, it's not. I don't want it to be fancy and complicated for the sake of being a science experiment. I want it to be fancy and complicated so that a machine can really help me do what machines do best. Absolutely. Which is run the data applications and give me an action, right? And it doesn't have to be go do this. It can be like the way I think about customization in terms of data analytics is that whether it's a report, meaning raw data, or some sort of graphical representation, I'm perpetually after visualization, particularly visualizations that help things pop out or help bring things to the forefront or help prioritize things, right? My job will literally never end. There will never stop being problems in buildings in terms of mechanical or electrical systems, right? These are things that the modern we have chosen to build because we wanted to do something else with them. Or something else in that facility. So prioritization, is really what I'm after. And like we've talked about this whole podcast, there's a lot of ways to prioritize what you should work on. And so that's in many ways my job is trying to figure out what gets the first crack. Yeah, triage into different categories and different priorities. That's correct. Kind of a segue, but also kind of related is. So you mentioned MSIs, you've mentioned your team who's involved in FDD, you've mentioned your controls teams, right? The people that, get the controls upgraded and up and running and programmed and all of that. Can you talk about technology from a workforce standpoint and kind of how you think about all of these different teams
working together? And that's a really broad question, but that's kind of what I'm thinking about.
Okay. Yeah. Let's see where this goes. So you're right. I've inherited and hired folks. And I mean, I cannot praise my folks enough. I am successful because they are successful professionally. Like these are great people, and I love working with them all. The things that well, let me say this: I would say we are highly self-sufficient in our automation systems. Meaning, I have folks that can actually go troubleshoot instrumentation. I have folks that can troubleshoot the network connectivity and the communication between IO and controllers to software, and I have great IT support, and sort of the software management end. There's just not enough of those people, right?
Right. I was going to say the fact that you're talking about having great people at both of those levels of the organization is pretty rare.
Yeah, it is rare, and I recognize that is great fortune, and I hope to build that. So my leadership role here is to continue to be an organization builder. And that means like in many ways, a trainer. So for example, like on the controls technician end, and I'm not directly managing our controls techs. I got a couple staff members that are absolutely doing that and doing the supervisory and dispatch stuff. We're talking about at this point, because there's just not enough people, trying to find people that are can know their way around a multimeter and can be an okay electronics troubleshooter, and then just teaching them what they need to know about building automation. We're going to have to do that to be successful at that. Alternatively, and this is in some cases my story and several of my team member stories, we all came from other professional settings and got, I'll say, burnt out by other rat racy type stuff, and like kind of being in the same place, but still doing amazingly interesting professional work. So it's an attractive recruitment piece that I like to talk about. In terms of managing all the relationships, I'll say we in the last year, some due to COVID, some due to other influencing factors, we have tried to be much better and have much more rigorous and defined processes about what we do internally and what we reach out to our external service providers on, right? Mm-hmm. And that's been a little harder to implement than I thought it would be, only because I'm basically going out there and saying, I will give you money to help me solve problems, and I want to do that as efficiently as possible. And but what that has meant is that I'm going to several vendors, traditional controls companies, MSIs, and telling them the way their businesses are set up just don't work moving forward.
Okay.
So the thing.
Can you give us some examples?
Yeah, right. If I call the one of the large 4 legacy building automation providers that I've relied on for many years and tell them, look, there's something going on with my, with BACnet network health, right? The first thing they do, or the first thing they want to do, is dispatch a service technician to my site, which is not the first thing they should do. The first thing they should do is, if they assign it to the service technician, confirm that he's the right guy that can remotely log into my system, because we give our vendors appropriate remote access, secure remote access, and look and see what where's the breakdown, right? Is a controller or a PLC getting that signal or not? Okay, if it's getting the signal, then there's something else upstream of that, right? And so I think the industry is really struggling right now in the sort of I guess we'll call it the IT to OT crossover.
Yeah.
That is a major hole. And those are where I hope to recruit, train, find other vendor partners that are really good at that, and being really efficient at that level of troubleshooting, more cost efficient, better use of resources, hopefully leads to less frustration, more uptime, more data consistency, and all the other things that I need to do with that. And I actually probably think that I haven't skinned this cat all the way, but I think you can basically say, I can take a controls guy and teach him enough IT stuff to be functional there, or I can take an IT guy and teach him enough of sort of the engineering and mechanics side of those things. I think both of those things are viable. I don't know, I don't have a right way to do that.
Which
yet.
one? Yeah, it is.
Yeah, right.
But we just know that we have to cross the boundaries in some way.
That's exactly right.
Left to right or right to left. Yeah. One of the ways.
Yeah. And that's what everybody in this space, and I'm assuming a lot of the conversations you have with listeners and just what you work on with Nexus, that's the problem to solve, because by and large, Siemens or Honeywell like their controllers work, right? You can put them out in the field and they last for 25 years, right? That's not the problem.
That's not the problem.
If you land the wire right, that's not the problem.
Mm-hmm.
When something's not talking to a server or one server can't talk to another server, that's where the problems are.
Got it. I don't know why I want to ask you this, but what do you think the future of those companies then is from your standpoint?
Oh, I think they will hang on to their, I want to say, monopoly structure for as long as they can, which is a shame. I think that is a disservice to the customer, is a disservice to the industry. The reason, because I think ultimately they'll fail in kind of a bad way from a service perspective. I'll say that while conversely hoping that they improve. If everybody were on sort of like open platform, independent, distribution and sales channels and service, that's great for some folks if you have a really good person in your backyard. But that's hard too, right? So what I hope doesn't happen is that I'll say the big four fail to change. Their businesses blow up. That'll be a several year evolution for like the right collections of people to get integrated into some third party support vendor and then provide customers what they need, right? That'd be highly disruptive. And for somebody like me, right? Like there's like 40,000 people on this campus that depend on my stuff working right. And, I've got a great in-house team, but we still depend on those outside folks for a lot of our assistance. So I don't want that to happen.
Totally. All right. Last question I have for you related to professional stuff is your role. So when we teach our foundations course, we talk about this role of what we call the smart buildings champion, but it could be decarbonization champion. It could be, energy champion. The word champion is like, okay, I recognize all these different organizational silos in my organization, and I need to be the one that, jumps over those gaps and gets people kind of moving in the same direction, right? Same sheet of music, whatever metaphor you want to use there. Can you talk about how you do that and the skills required in a succinct way? Or is that another podcast?
Oh man, I'm sure it's another podcast, right? I'm sure. That's a great, so, some of what you're asking there is there's a little bit of leadership in there. There's a little bit of salesmanship. There's a smattering of a couple other things, but let me try to answer this in as best way I can. The further I get into my engineering career, the more important I recognize like that just team building is, period. That is so true in the energy space. And I don't think it will ever stop being true because energy is like everything and everywhere, right? The reason that we talk about it as a utility is because it's this great societal enabler and I don't think stops. So I put a lot of time, like a whole lot of time into being just a relationship manager, which is interesting to me for a couple of reasons. One, I really enjoy my position professionally. Like I really enjoy my job. I could have never told my 21-year-old self like how to get from like ending college to where I am now. Like I just would have, I couldn't describe that path. I am where I am.
Me neither.
But the stuff that we do aren't these little kind of projects that last for 6 months. Like we don't build an app for 6 months and then boom, and we deliver it and it's done. Right.
Yeah.
I don't even design, an HVAC system and hand it off to somebody to go build it and boom, it's done. Right. The decisions I make have really long lasting impacts and they are worth a lot of money. And I try to recognize that. And instead of that being a grave weight, I try to put a whole lot of optimism to that. The conversations that have popped up in, I'll say, like popular media, like the layperson's media about whether or not the world will actually limit climate change to 2 degrees C, right? There are plenty of people that say like, no, we're not going to do it, right? I don't have a direct response to that in the like, oh yes, we can, but I am like perpetually optimistic at what we might be able to do for the good for as long as we are here, right? So that's something. I try to be with my team like infectious about that, right? That's something that matters a lot to me, and that doesn't mean I want to convince everybody to like love their job, right? And nor do I want to convince everyone that they should be an extroverted, quite happy person. You don't have to be that, but one of the things that is absolutely true in our profession is that what we do matters, and it matters to people even if they don't know it. when you run facilities and you run energy systems, like you run the world. and that's a really unique and neat opportunity that I'm proud to be a part of. And that's the thing that I hope the US can get better at, is like trying to encourage particularly technical education to get more people involved in this field. You don't need a 4-year college degree to do a lot of the stuff, that a lot of the trades and a lot of the skills that need to happen in the building and automation and energy world. And so I look forward to like just a reinvigoration of that. And it's hard, like it's hard work. In some cases it's physical work, but it's a lot better than, this is going to sound snarky and mean, it's a lot better than having an art degree and working in a data center or in a call center, right? You're doing something that matters.
Yeah.
Yeah.
And I'll say, just looking at your career, you've gone from engineer to really more of a generalist that's bringing all these people together. That champion role is the one that's kind of bridging all these gaps, knowing Absolutely. Who can go deep on what topic and where do I go for this and where do I go for that and how do I get this person on board.
Yeah.
And I would also encourage like people that are in that technical space to brush up on those types of storytelling, marketing, sales, leadership skills. That's something that I've always been interested in. Like, I've never really wanted to go deeper technically than I did when I was, the first 5 years of my career, basically. Like that was pretty much it from a technical standpoint. But, I found myself reading Seth Godin on marketing at night, like things like that I just needed to understand. Okay, yeah, we have these technical problems, but how are they then showing up in the world? And then how can we change the world based on, selling this new technical idea or, that kind of thing. And it seems like that's been really important for you as well.
For sure. I would, yes, fully agree with that. For example, I'm involved in stakeholder conversations about regulatory and policy changes, right? And I do a disservice to our entire sphere if I show up and be an overly technical engineer in that room, right? That's terrible. I need to be able to succinctly and concisely and relatably convey why distributed generation matters or why, energy deregulation matters to the economy or to like pick a thing. So that a staff lawyer at a public utility commission can say like, yeah, okay, I get that. Up the chain, I'm a subject matter expert. Down the chain, I'm a champion and a cheerleader and I am absolutely a connector. And I love that I get to work with a lot of people that are smarter than me. Like I always tell people, I'm a pretty good engineer. Like I'm just a pretty good engineer.
Yeah.
But I am a way better connector. And at this point, knowing I have I hope a long career and a long life, I'm like a pretty good team builder. And I take a lot of pride in that, and I want to keep getting better at that.
That's great. All right, Casey. Well, thanks for taking me through all those detailed questions. That might be the most questions I've asked in the show so far. So appreciate you going deep. Let's end this with Carveouts. So what book, movie, TV show, podcast, or other link would you recommend the audience checks out?
All right. You had a lot of I've got a lot of answers on this one to your single question. So we'll flip. Okay. Let's see. A couple podcasts. I'm a big 99% Invisible listener. Okay. I just absolutely love that one. That was That's maybe like early podcast intro to me,
Yeah. Okay.
And I think the shows continue to get pretty good. There's a podcast called Energy Transition, which is pretty wonky, but it's one of the few podcasts that I pay for. So I guess I'll endorse it that way. Not a short form, right? You're going to set aside an hour plus, but it's thorough and well done. Let's see. I'm a big reader. I really love a lot of history and I love a lot of, especially history of technology. Right? I just think it's neat how that's in many ways, that's what makes us human, right? We figured out how to use some things I can throw out there. These are a little bit dated now, but there are 2 books by an author named Daniel Yergin. And in the 80s, he wrote a book named The Prize, which is all about how really the oil industry. And then he followed up in the early 2000s, mid 2000s with a book called The Quest, which is a lot about energy transition. Those for me were like hugely important to just how I think about our energy industry and transition. The Quest in particular. The Prize is interesting because, once you read it, you're like, well, shoot, the entire like 1900 to 1999 was like literally just oil. Like that was world history, was whatever the oil industry was doing. Fantastically enlightening and also frustrating if you if you want the world to look differently. Let's
Okay.
see. Let's see. There's a good book I like called On Grand Strategy by a guy named John Lewis Gaddis, who's I think a professor at Yale or Harvard, which is great because it's just a way. It frames in a very interesting way how to solve problems and how to think about like just strategic planning, and not in a business school kind of sense, more in a look back at history, right? How did this empire do it? Like, let's look at that as almost a illustrative case study.
Okay.
Not super long, fantastically interesting. Let's see, novel wise, I really like John Le Carre, who's a spy writer writing from the 60s all the way to the present. If you know of his, let's see, Tinker Tailor Soldier Spy is one of his novels that got turned into a movie. Some people knew that, but those are great because those are, it's like the anti James Bond. It's all about spies and all the sort of like bureaucratic inside nonsense and inefficiency and silliness. I like those because there's not a clear good guy and bad guy. And that's how the world works. And it's just a great it's a great observation and a lot of it's set against sort of Cold War conflict. Okay. Really cool, just great books. Last one I want to mention actually is A.A. Milne, who's the author of the Winnie the Pooh books. One of his books is called Now We Are Six, which is a book of children's poetry. But you can't not read that book and find something relatable. You can't not read the poems and not find something relatable to like literally everyday situations. It's just great. Okay. Which might mean that I have a 6-year-old's mind when it comes to reading poetry, and I'm just not that sophisticated, but I love it. Read it with my daughter all the time and read it myself too. So
nice.
Yeah.
That's beautiful. I'll have to check that out. Sounds like a great gift for like child and parent.
Indeed. Yeah, absolutely a great gift.
Got it.
Yeah.
Okay. Yeah, I like that. That's a great collection. Thank you. I only share one a week because I do this every week. So the one that I'll share this week is relevant for you. And I just picked it up over the weekend and started reading it last night. It's called Colorado 14er Disasters. So I like climbing 14ers. I haven't done that many. It's not impressive what I've done at all, but I enjoy it. And this book caught my eye in the bookstore, and I'm one story into it, and I can recommend it just from that one story so far. Nice. It talks about exactly what happened, kind of like case report, rescue report, and then obviously goes into detail on who the person is. And then it dissects all the ways in which the person messed up that led to their untimely death. So as someone that I like to do solo 14ers as well. So it has enlightened me on all the ways in which I've done stupid things and got away with it so far. And I won't do those things again. So anyone that likes climbing should check that out.
Nice. I'll look for that one for sure. Appreciate the recommendation.
Sounds good, Casey. Well, thanks for doing this. Thanks for sharing everything that's going on in Duke.
Glad to. It was a lot of fun. I appreciate the invitation. And again, thanks. Thanks for doing this podcast. It's been a great resource for me to think about stuff. I look forward to continued development.
All right, friends. Thanks for listening to this episode of the Nexus Podcast. For more episodes like this and to get the weekly Nexus newsletter, which, by the way, readers have said is the best way to stay up to date on the future of the smart buildings industry, please subscribe at nexuslabs.online. You can find the show notes for this conversation there as well. Have a great day.